could get to work a lot faster.
Look how big this is.
Anyway.
Oh my goodness.
They don't make you
Wow. This is incredible. This is absolutely incredible. This is bigger than bigger than my car. This is huge. This is bigger than a car. I'm here at the Science Center here in LA right now, and I'm here with George right here, and he's going to talk about this very big engine. So tell us a little bit about it.
Well, first I have to give you a warning. And my warning is, please do not even consider using this engine on your hot rod.
Oh, okay, yeah. Definitely not.
Because it's equivalent to 12 million horsepower.
12 million horsepower.
And that will blow you away.
Wow.
So it uses hydrogen as the fuel. This red is the pathway for the hydrogen to come in.
Okay.
And it uses oxygen with a green strap as the oxidizer. So the exhaust that comes out is none other than H2O, which is in the form of steam.
Okay.
So it's very clean burning rocket.
It's very interesting, yeah.
And there are 3 of these were used on the Space Shuttle.
Okay, so 3 of these are on the Space Shuttle.
And it took only 8 minutes to get to space.
Wow.
They had booster rockets to get off the ground. They burn for 2 minutes and then they drop off. And then these go all the way to space, which is only 100 miles up. You're considered you're in space. The shuttle orbited between 150 and 200 miles. Have to travel 17,500 miles an hour to avoid gravity bringing them back. Everybody thinks they go up in 0G, but it's not 0G. They're balancing the centrifugal force of the speed going in a circle with the gravity.
That's amazing, yeah.
And when they want to come back to Earth,
oh yeah, when they come back,
they fire the thruster rockets on top because the fuel's all gone for this. It uses all the fuel in 8 minutes.
Oh,
the tank drops off. So to come back, they turn around backwards and fire those thrusters, which slows it down. And once it goes slower than 17,500, the gravity starts to bring them back to Earth. So they're floating because they're balancing the forces of the motion with they're free falling basically.
Oh, okay. That's very cool.
Any other questions?
Like how long does this take to build, or where was this manufactured? Can you explain that a little bit?
Manufactured here in the Los Angeles area in Canoga Park. We call it in the valley. It was owned by Rocketdyne, and it took a lot of development. It took about 4 or 5 years to perfect it. They won the contract against Pratt & Whitney back east, but they invented a new alloy that simplified the design.
Okay, so now it's probably a different design from what it was before now. Would you say that?
Well, than the other rockets by the other companies. It was more modern. And now they've improved it more. For example, electronics. They're using this on the new NASA SLS rocket. And I guarantee the electronics box is not going to be that big on the new one.
Oh, wow.
Because there's so much progress in electronics.
Right, yeah.
It'll probably the size of an iPad or an
Right, it just shrinks down, yeah.
Yeah.
The components
So
shrink
small.
down, yeah.
But basically, and they use part of the fuel. There's a 4-way valve. Part of the fuel is used to cool the nozzle. The nozzle's made out of over 1,000 tubes to flow the hydrogen back to keep it from melting.
It's very interesting. Wow. Yeah, thank you for that. A lot of good information.
Okay.
All right, thank you, George.
Thank you.
Appreciate it.